Hey science lovers, welcome back to the channel, where we explore the wild, the wacky, and the downright mind-blowing world of science. Today, we've got 10 crazy unique science experiments that you can do right at home. Yeah, you heard that right. You won't believe how simple some of these are, but trust me, they're going to blow your mind. We're talking about turning ordinary household items into tools of scientific discovery. No need for fancy labs or expensive equipment. If you've got some basic supplies and a thirst for knowledge, you're in for a treat. We've got everything from color-changing liquids to objects that seem to defy gravity. Make sure to stick around for number 1, because it's not only awesome, but also something you'd never expect. Let's dive in. Alright, science explorers, let's kick things off with a bang. Our first experiment is a classic, and for a good reason. It's called walking water, and it's all about demonstrating the power of capillary action. Here's what you'll need. 3 empty glasses, water, some food coloring, let's go with red, yellow, and blue, and some paper towels. Fill 2 of the glasses with water, about 2/3 full. Add a few drops of red food coloring to one glass, and a few drops of blue to the other. Mix it up good. The third glass, that's our empty glass, for now. Fold paper towels lengthwise to create sturdy strips. Place one end of a paper towel strip into the red water and the other end into the empty glass. Repeat with another strip for the blue water. And now, we wait. You'll see the water slowly creeping up the paper towels like it's climbing a ladder. This is capillary action in action. It's the same force that allows trees to pull water from the ground up to their leaves. Pretty neat, huh? Get ready to chill out with our next experiment, because we're about to unlock the secrets of supercooling. It sounds complicated, but trust me, it's as cool as it gets, literally. Here's what you need. A bottle of purified water and your freezer. Take that bottle of purified water and pop it into the freezer. We want to supercool it, so set a timer for about 2 hours. This should be enough time for the water to chill below its freezing point without actually turning into ice. While you're waiting, let's talk about why this works. Water normally freezes at 0 degrees Celsius or 32 degrees Fahrenheit. But with supercooling, we're tricking the water molecules into staying in a liquid state even below their freezing point. Ding, timer's up. Carefully take the bottle out of the freezer. Try not to jostle it too much. Now for the grand finale. Give the bottle a firm tap on the bottom or pour the supercooled water over ice cubes. Boom! Instant ice. The supercooled water instantly freezes upon contact with the ice cubes or even just a slight disturbance. It's like you have ice powers. Who's ready for some chemical magic? This experiment is a classic for a reason. It's simple, fun, and demonstrates the power of chemical reactions. You'll need a bottle, vinegar, baking soda, a balloon, and maybe a funnel. Pour some vinegar into the bottle. About 1/4 should do. Funnel a couple of tablespoons of baking soda into the balloon. Stretch the balloon over the bottle's mouth. Hold the balloon upright so the baking soda falls into the vinegar. Watch the fizzing reaction as carbon dioxide gas is created. The balloon inflates as the gas has nowhere to go but up. Alright, science sleuths, get ready to dive into the world of non-Newtonian fluids. Don't let the names scare you. It's not as complicated as it sounds. In fact, you can create this mind-bending substance right in your kitchen with just 2 simple ingredients. For this experiment, you'll need cornstarch and water. Grab a bowl and pour in some cornstarch. Slowly add water, mixing it with your hands as you go. Keep adding water and mixing until the cornstarch mixture reaches a consistency that's, well, weird. It should feel firm when you squeeze it, but then ooze out of your hand like a thick liquid when you release the pressure. Try punching the mixture, don't hold back, and you'll be amazed to find that your hand doesn't splash through. Slowly dip your fingers into the mixture, and it will behave like a normal liquid. But try to move your hand quickly through it, and it will resist, almost as if it's a solid again. Non-Newtonian fluids don't play by the same rules as regular liquids. Their viscosity changes depending on the force applied to them. Get ready for a fiery spectacle that will have you questioning everything you thought you knew about balloons. This experiment involves fire, so remember, safety first. Always have an adult present and take all necessary precautions. Here's what you'll need: a balloon, water, and a lighter or a candle. Fill the balloon with water, about halfway is perfect. Tie off the balloon securely, making sure there are no leaks. Light the candle or lighter. Hold the water-filled balloon over the flame. Wait, what? The balloon isn't popping. You'd think the heat would weaken the latex and cause it to burst, but instead, the balloon remains intact. That's because the water inside is acting as a heat sink, absorbing the heat from the flame and preventing the balloon's latex from reaching its melting point. The water is sacrificing itself to protect the balloon. See, science can be heartwarming too. Get ready to unleash your inner magician with this gravity-defying experiment. We're going to make a ping pong ball float in midair. And no, it doesn't involve strings or trickery. It's all about the power of air pressure. For this bit of scientific wizardry, you'll need a ping pong ball and a hairdryer. Make sure your hairdryer is plugged in and ready to go. Turn the hairdryer on to a cool setting and point the nozzle upwards. Hold the ping pong ball a few inches above the hairdryer's nozzle and let go. Whoa! The ping pong ball floats. It's like it's magically suspended in midair, defying the pull of gravity. You can even move the hairdryer from side to side, and the ping pong ball will follow, staying within the airstream. It's like the air is creating an invisible force field, keeping the ball aloft. So, what's the science behind this floating phenomenon? It's all about air pressure and Bernoulli's principle. When the hairdryer is turned on, it creates a high-velocity stream of air. This fast-moving air has lower pressure than the surrounding still air. Get ready to light up your world with the power of fruit. We're going to power a light bulb using nothing but lemons. It's a classic demonstration of how chemical reactions create electricity. You will need 4 to 5 lemons, copper coins, zinc-coated nails, wires, and an LED light bulb. Roll the lemons to get the juices flowing. Insert a copper coin and a zinc-coated nail into each lemon. Connect wires between the lemons, positive to negative. Attach the wires to the LED light bulb. The LED light bulb should light up, powered by the lemons. Get ready for a dazzling display of color with this mesmerizing experiment. We're turning ordinary milk into a swirling canvas of color with a touch of dish soap. You'll need a shallow dish, whole milk, food coloring, dish soap, and a cotton swab. Pour enough milk to cover the bottom. Add drops of food coloring to the center. Dip the cotton swab in dish soap. Touch the soapy swab to the food coloring. Watch the colors swirl and mix, creating a mesmerizing display. Get ready for an excellent demonstration of air pressure. We're going to make an egg magically get sucked into a bottle, and no, we won't be using any tricks or illusions. It's all about the power of science. For this gravity-defying experiment, you'll need a hard-boiled egg, peeled and ready to go, a glass bottle with a neck slightly smaller than the egg, a small piece of paper, and a lighter or matches. Carefully light the piece of paper with the lighter or matches, and drop it into the bottle. Quickly place the hard-boiled egg on top of the bottle, sealing the opening. Watch closely. The flame will consume the oxygen inside the bottle, creating a lower air pressure inside. The higher air pressure outside the bottle will then push the egg down into the bottle. It's like the bottle is inhaling the egg. The egg acts as a plug, sealing the bottle and creating a difference in air pressure. The higher pressure outside the bottle forces the egg inside, even though it seems impossible at first glance. Science is amazing. Get ready to unleash your inner spy with this classic invisible ink experiment. We're going back to basics, using a simple household ingredient to create secret messages that only those in the know can reveal. For this clandestine experiment, you'll need a lemon, a cotton swab, a piece of white paper, a heat source, like a light bulb or an iron, and your top secret message in mind. Cut the lemon in half and dip the cotton swab into the lemon juice. Use the lemon-soaked cotton swab to write your secret message on the white paper. Let the lemon juice dry completely. Once it's dry, your message will be invisible to the naked eye. Carefully hold the paper up to the heat source, moving it back and forth to avoid burning. As the heat touches the lemon juice, it will oxidize and turn brown, revealing your hidden message as if by magic. You've just created a secret communication system using nothing but a lemon. Now you can exchange secret messages with your friends, just like real spies. That's a wrap. So there you have it, science explorers. 10 mind-blowing experiments you can do right at home using everyday materials. Which one was your favorite? Let me know in the comments below. And don't forget to share this video with your friends. It's the perfect way to blow their minds with science. Make sure to hit that subscribe button and turn on notifications so you never miss out on more cool experiments. Until next time, stay curious and keep experimenting.